Yep, got it. Okay. Hey, good morning, good afternoon, or good evening, wherever you are in the world. So, got this new, really cool new gadget here. It's got unlimited battery life. Reflective. I mean, it's amazing. It's like, I don't know, I think it's better than like a nano texture display. It's like, it works, like you can really see it from any angle. It's really good. And super crisp. The resolution, I don't know, like it's pretty much as good as I can, I can't see the pixels. And yeah, I don't know, like it's like super lightweight, super durable. Yeah, it's good. So I'll just try and use that today, because definitely yesterday, if you were watching yesterday's stream, there was probably about like 4 or 5 hours of some real struggle street. Definitely to do with one, like not thinking about the problem, like not kind of visualizing it, not thinking about it in a different way. And secondly, like really shitty testing. So I've done this to avoid yesterday's stuff up. But we did get there in the end. So let's look at, I mean, this can all go now. Let's say today, what day is it today? We're the 13th of June, wow. So what we need to do is we need to tidy up yesterday's work. Okay, we want to commit the stuff. After that, what we want to do is we're going to take our MPEG transport stream package and actually put it to work. So I'll just draw it out here, but what we have right now is we've got OBS that goes to FFmpeg, and then that goes just eventually out to Twitch and YouTube. But we also have a self-hosted stream. So in that instance, what we've got going is we've got OBS running at TCP MPEG-TS. And that one's actually going to a server that we've got running in on the west coast of the USA. And that thing receives the MPEG transport stream and then just dumps it straight to disk as a few .ts files. So we've got our program, and then what that does is that we call this HLS serve, and what HLS serve does is that it reads in the transport stream and what does it do? Yeah, and then serves an HLS playlist. So then you got, people can fetch stuff over HLS. So right now how it works is you got a dog barking, and that helps to do software development. So yeah, what we've got here is the program actually just splits it up, just counting 188 bytes at a time. So it'll just read 188 and then times some number, let's call it X, and then it'll dump it. 188 times X and then dump it. So it's really just doing it with basically just counting bytes. Now that's cool, and that it's really like, that's a handy thing about MPEG transport stream, that it works like that. But what I think we can do is that instead of doing, instead of just counting the bytes, what we can do is kind of a little bit of a silly process. It's kind of not much point, but it is going to be good to like exercise the system or exercise the package. Is instead, we're going to get this thing from a TCP connection, and we're going to read it in with our MPEG transport stream decoder. So we're going to decode, and then we're going to encode it again, and then we're going to write it to disk. So we're just going to see like what happens, because, you know, that's going over the internet. So there's going to be all sorts of, you know, bits and pieces that are going weird, you know. And yeah, I just think it'll be interesting to see if it really works. Oops, sorry, I just realized that isn't super clear, but you know, kind of see it there. So yeah, that'll involve, of course, like doing like better sort of let's say like better memory management than we're doing now. Like right now, we're just allocating 188 bytes for every single packet, which is, you know, terrible. So we can just have a like fixed buffer and then do it like that. And that'll be a nice little interface. So we'll have like a thing called, I'm going to call it a scanner. And yeah. So let's go, I reckon. Let's just continue, because we need to, you know, whoops. Oh yeah, new. Let's fix this up. Give me a sec. I'm just fixing that up. It's not any different, is it? There we go. I'm not sure whether that's really super clear. Yeah, let's should be all right. Let's go. Oh no, we're not doing SCSI. What are we doing here? MPEG transport stream. Okay, so we finished up yesterday by finally having our test pass, where we read in the transport stream packets, decode them, re-encode them again, and then do a byte for byte check. So right now that's actually working, which is cool. Why that's fun is before we weren't, at the moment we're reaching into the payload and trying to decode some of it. So there's a little bit of a management there, because like some of the stuff we do handle and some of it we don't. So we're kind of like, yeah, we need to make sure that we're splitting up our, like aligning our buffers and stuff like that correctly. Also, our timestamp unpacking and packing was a bit wonky, but that's all sorted out now as well. So that's cool. Let's start. So we're gonna have, tidy up the tests. And then yeah, then commit. Okay, I've called this unpack timestamp. Just because I think that's feels better to me to do it like that. And package documentation, indeed, yes. Yeah, that's right, yeah. Yeah, let's do that. And the documentation here is going to be super important because the way the code around packing and unpacking the timestamp is pretty, like, it's, you know, it's confusing. It's kind of counterintuitive, right? Like, it's all, yeah. So that needs some, yeah, that needs some love. It doesn't need love, like, it just needs, yeah, it just needs to be written down. So, yeah, let's go to timestamp first. Okay. Am I streaming full chunk? I don't know what that means. Oh, hey, you know what I just realized? I forgot to, let me set up the self-hosted stream. Yeah, that's right. Cool. Okay, and then if we do that, okay, there we go. All right, so that now should be going. So we'll leave that. There we go. In text room we have chunking left. I think I just such a per chunk. Well, say you didn't receive a clean feed, it can double up and send chunk again, then never lose any video. Okay, yeah, I see what you mean. Yeah, so in this case, the answer is, say you didn't receive it, it can double up and send chunk, but then never lose any video. Yeah, so in this case, we are not doing that. Well, we're not handling that, but TCP is doing a lot of heavy lifting for us. So right now how it works is that we've got the, I suppose something like buffering. Yeah, I mean, I suppose the, you know, the operating system and the everything all the way from, you know, one end to the other that's helping. But also MPEG transport stream itself, like it's kind of designed to just lose stuff. So it doesn't really care. So there's quite a bit of overhead in the actual packet, which we can see there's all this stuff here. Okay. With large language stream. Yeah, okay. Yeah. So, yep. So, there's a few other protocols that do this kind of thing. So, for example, SRT does this. So it has a bunch of checking to say like, hey, like, did you actually receive it? The other one I think that handles this, at least a little bit of it, is RTP. I think, but we'll actually look at that because we'll do RTP, I think, pretty much after this. The way MPEG transport stream handles it is you basically just keep sending stuff, and then every few packets will have, well, certainly every single packet actually, and there's a whole bunch of other. The recommendation is about every 10 packets you have to send the clock reference. So that's the thing that tells you, hey, like this is where I'm up to. I don't know where you are up to, but this is where I'm up to. So then the decoder can go, oh shit, okay, I need to kind of skip along, or I need to go back, or I need to slow down, or I need to do whatever. So, yeah, because it's a very dumb pipe. Now we're using TCP, which helps us a lot there because that does a bunch of reordering and all that stuff for us. But you can do MPEG transport stream over raw UDP, and in that case, well, like who knows what's happening. And that's how I'm actually sending the video from this, like right here. I'm on an older laptop, and then that's just blasting packets to another computer that's actually, which is running OBS, and then it's doing the whole thing and then sending it out again. It's just a flaw with current streaming systems. They're always losing video frames. I would prefer the stream to pause and restart where it was. Maybe have a fast forward section to the current point in time temporarily. Not really any Twitch stream has thought about it like this. So yeah, this is one of the things with sort of with video systems is there's always going to be a trade-off between latency and reliability, and that's essentially pretty much everything that we're dealing with. Like all of this stuff is just like a whole bunch of trade-offs and all this sort of thing. So that's kind of what makes it fun and interesting, is that you're kind of juggling like these different things. Well, like, should we do this or should we do that? And there's a whole bunch of different approaches. And yeah. How much local buffer would we need to do something like that? 4 to 5 minutes. Well, and to fast forward the content into the stream, inject that. Well, it depends on what layer you want to buffer as well. So there's fast forward the content into the stream. Well, I mean, right now, like players actually do this. It's just that the recommendation right now, if you're doing HLS, I think they say you have to have at least. Yeah, exactly. Yeah, MPV but it actually has a little algorithm. It's what was it? Is it 3 times the duration of the segment or something? Like 12 seconds? I can't quite remember. Yeah. But yeah, and then there's buffering at all many different layers as well, right? So yeah. then hop to the live stream again. Yeah, and indeed, yeah, MPV and FF play, all, yeah, you can adjust it. You can even have no buffer, which is interesting. Yeah. If the player fails the connection, it times the amount of downtime, wraps up the file and codes on the fly and ships that file. Okay, wraps up the file and codes on the fly, ships that file with a fast forward to the current frame, then hop to the live stream again. Oh, you think so to go back? Yeah, so... yeah, look, there's a few too many, I think, yeah, it's hard to talk about unless you start talking about the layers that are actually involved. So for example, like capturing from the device directly, I mean, there's a whole bunch of buffering there as well, right? Yeah. So and then past 10 minutes, player fails internet connection. Okay, like if one player, is this point to point or is it... Yeah, there's a bunch of different things there that's, yeah. Like player to cloud. AWS infra with CDN. AWS infra. AWS, so you're talking, what, maybe, player to cloud, AWS infra with CDN. Oh, okay. What I would recommend is have a look at, okay, I see what you mean. Okay, so this is actually how these ingest, they call them ingest protocols, but it's just, they're not necessarily just for ingest. But right now, yeah, this is actually how RTMP and SRT work. So what I'd recommend, and just because we're getting a bit distracted, so I'll just, but if I send in, there's a few interesting articles that I'll, what's that one? Let's do Max. There's DIY app. Is this it? Yeah, this is a good one. So I'll just share that article. And then the other ones to look at are RTMP. I'll just do that, and then probably just a Wikipedia article just to start with. And then the other one would be also go to the disintegration page and then go to secure. Yeah, that's it. Hey, how's it going? Hey, everybody. Yeah, so have a look at those because there's, in terms of like the, yeah, it's super interesting. Action is not actually a bot. Is it Twitch or the PC? Either end. Yeah. So something like the, I can't remember if with RTMP there's a, I haven't studied the protocol too well, but there's a, with RTMP there's a bunch of, is like commands or actions or something. And I think, yeah, there's something that lets the, yeah. something that lets the receiver know that, okay, like it's time to go. And RTMP itself is also on TCP, right? So any sort of signaling that you want to do with TCP will also kind of work, I guess. With SRT, there is a caller end and a listener end. Is that right? Yeah, and so yeah, there's a bunch of stuff in the protocol to handle like gracefully terminating the actual stream, which is different from, for example, like, you know, actually losing a, you know, maybe losing a connection or dropping it, or, you know, you haven't heard from them in a little while. I've seen a few interesting things on SRT, which kind of maybe makes studying SRT makes it a bit easier to understand the challenges with this kind of ingest, the ingest part of video streaming. Just because the protocol like has a lot of things baked in that, you know, deal with the kinds of problems that you have. Is it possible to predict in the future exactly when streams may drop, then just send the data through a different ISP? Yeah, sure. I mean, yeah, there's a whole, and again, like with, if you imagine like, you know, like that OSI layer model, right? Like, so there's a whole bunch of different ways to handle this sort of stuff. So, yeah, like, yeah, it's, you know, if multicast, you know, like multipath TCP, I guess, is another thing. Yeah, often with these things, they'll, in the real world, like they just have a bunch of redundant, I mean, of course, again, it depends on, you know, which part of the chain you're sort of working on, but yeah, I'd need to draw diagrams out and stuff like that and kind of, yeah, and again, like there's a whole bunch of different strategies too. Yeah, but yeah, no, it is, it's interesting. Yeah, it kind of, as I always say, it feels like technology rather than like kind of software stuff, if that, you know, a little bit of a difference, I guess. Yeah. Yeah. That's cool. Action is not actually a bot. I get that. Yeah. Okay. All right. Yeah. So let's let's go. I was gonna start in. Let's document this little function here, just because it's a bit of a bitch. I'm gonna do the timestamp is. Oh, okay. Yeah, it looks like the font doesn't... Yeah, I need to change the font. Maybe it's like with the... Yeah. With yeah, that's right. Yeah. So this part's pretty tricky. So what these so these work out to be bits. So I'm just going to put in monospace for a sec, just so we get this diagram out. But these are our 5 bytes that the timestamp is encoded with. I might actually do this on paper, actually. Yeah, I'm going to do it like this. All right, so we got byte 0, 1, 2, 3, and 4. Now we've got some bits that are just like padding, so that's 0. And then we've got a flag. Is this actually showing up? Yeah, sweet, okay. And then we've also got another bit here. So this one here, so this P is, this is indicating that the actual timestamp is, I'm not quite sure how to word this yet. This is why I'm having trouble with it, but it's saying that the actual timestamp is expected to be like, that there's a presentation timestamp that's sort of related to this timestamp or something like that. It's hard to, yeah, it's, that indicates sort of the, maybe indicates the presence of a presentation timestamp in, yeah, with this timestamp basically. So anyway, let's just get this right. So then I'm going to use T for the actual 33-bit integer that's packed in here. So there's that, and we're going to have timestamp, 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 and then we're going to have a check bit. So let's call it C, and this is just always a value 1. And as we go, we're going to have, you know, timestamp, timestamp. So 1, 2, 4, 1, 2, 3, 4. The timestamp bits. And then we're going to have a check bit again. Let me just check that's right. Yep. And then timestamp 4, and then I'm going to have timestamps here. 1, 2, oops, 2, and then a check bit there. So that's our like bit layout right there. So we're just going to document these flags here. That doesn't actually tell us whether it's whether this is actually a presentation timestamp or a decode timestamp. All it tells us is that there is that with this actual timestamp, you should expect to see those. So that's the kind of thing. I just, in case it's a timestamp, I'm not sure how to document that. Will contain, you know, or that this timestamp contains a decode timestamp, like that. It's not actually, it's not declaring that this, it's not declaring that these number of ticks is one thing or the other. It's just saying that there is one there, which is, yeah, I don't quite get it, but anyway. I imagine there's some kind of weird legacy reason or something. I don't know. It's kind of odd. in a PES packet header. And then should we say what it's actually used for? It is used by, you know, to correctly, you know, synchronize playback of PES packet, you know, of yep. Yeah, there we go. Or playback of video and audio, maybe. Or really anything, to be honest, but anyway. Oh, wow. Oh, yeah, thank you for the subscription. Yeah, no, sorry, I don't have it open. Should I have it open? Would that be... Yeah, let me... Look, you know what? Let me open this up. Sorry that I... Sorry. Just, yeah. Here we go. Let's open this up. Dash. Oh, wow, all these people raided. Oh, shit. Cool. Ah, super kind. Thank you so much, man. That's good that we can keep that self-hosted stream going with the funding. No ads, no nothing. No tracking, no logging even. Maybe there should be more logging because fucking, I don't know, might help troubleshoot it. Okay, let's format this thing. Oh yeah, that's fine. We'll just do it like that. Alrighty. So that's our timestamp documented. That's good. Okay, we definitely need to document this thing. Because this is a real bitch of a, you know, what the fuck? Like, what the fuck is that, right? Okay, let's title that up. So let's do it in A. Hey, how's it going? Just wanted to pop in before I go to bed. Oh no, yeah, very kind, thank you. Nice. Good to hear you had a good day. Mm-hmm. Can I let one rip? Oh yeah, like a Beyblade? is interspersed with how would we how do we do this with the bit layout in the following diagram or something like that? I don't know, with the I'm just going to write that. Okay, we'll grab that and then just jump that down here for now. Okay, so let's do it like this, and then let's grab this and indent it so that it becomes, you know, like pre-formatted text in any HTML layout. That's good, yep. The following bitfield diagram. Nice, thank you. So what we've got is we've got these zeros. So the leading zero, two leading zeros are padding. Hold the values for the PTS and DTS. Big are the 33-bit big endian encoded integer. Yeah? Is that? Let's see how that reads. Or rather, let's open it up and see like how most people are going to see the thing, which is oops. Which is going to, which is going to be in the Go doc. Oh no, that won't. Blah, blah, blah. I need to do Go doc. Hold up. Links. Ah, yeah, whatever. Okay, yeah, no, I guess I can't remember how to view the, like, the unexported, like the non-exported functions and stuff like that. But let's just, as it stands, this is... Diagram 0, 1, seeing it before it's generated is impressive. Okay, well that's actually pretty good. Go get rid of that. Good night, Kai314. Thanks very much. Good night, mate. Okay. Is that one documented? Whew, that was such a bitch. That was such a bitch last night. I don't know if anybody saw the final, like the final part of it, but essentially all that happened is that the final bug, which was probably the hardest one, was that I didn't have the little, what do you call that operator? The, let me get that first. Was it golang? I got to do such doc. Okay. What's that pipe operator? The bitwise OR operator? Is that the name of it? Bitwise OR, yeah, that's it. So I just didn't have a, I forgot a bitwise OR on a couple of the bytes. So that was that. Just totally crazy shit. And so, yeah, I found the bug and then I go, okay, and then ran the test, it passed, and I said, okay, good night, everybody. And then I just signed off because I was so done at that point. I was going for like 8 hours just fucking around, just, oh, ridiculous. Anyway, let's close that stuff. Okay. Nice. Okay, what I might do is, just because we've done documenting that bit, I'll just see if there's others. Oh, I actually need to document the PES. Yeah, this thing. Whoa, I think the stream's blipped. I don't know, it seems all right. Okay, I'm gonna have a quick tea break. Actually a quick lunch break. Autofocus, whoops. No. There we go. All right, sweet. All right. Very good. So, hey, see break, go boy, go. Yes, enhance. Yeah, the focus. Hey, how's it going? Oh man, last night. Oh my god, yeah. So, basically, it came about here. So, when we were packing these timestamps, it just took a really long time to get that working, really. And that was a combination of me being tired and stubborn and not relying too much on the testing that we had and not drawing it out properly. And of course, just some fucking, if I show you, you know, when I was packing the timestamp, you know, I forgot the bitwise OR operator on a couple of the bytes. So it's super funny. Like I watched the very final, like, you know, 60 seconds of the recording on YouTube, and it's just so fucking funny. It's just me going, it just magically worked, and I was like, fuck it, I'm done. After like hours and hours of fucking around with it. Yeah. Super funny though. And yeah. So, right now, what are we doing? We're just tidying up the PES, decode, encode. Okay, let's just check that. And we're documenting. Okay, so we're just going here, and we're gonna maybe I have to documenting these things. Let's actually document the PES packet itself. $300 tabs in Firefox? Is it because, do you not use bookmarks or something? Is that what's going on? Can't judge you. Hell yeah, I can. I guess so, yeah. Yeah. Yeah, it's winter, yeah. No, it actually gets quite cold in Sydney, yeah. I mean, well, okay, yeah. Yeah, you know. Yeah, I don't actually know what the weather is. 15. Fuck. Why does it feel so cold? It just feels fucking cold. Look at that, Melbourne 10. But see, what's happening is that it's the wind, see? Yeah, anyway. Yeah, exactly, yeah. Get a lot of rain in New South Wales. So on the coast, yeah. So there's a thing. Maybe I'll go here and then. No. But I mean, don't know if this will actually load on this computer, but we can give it a go. Oh yeah, there we go. So all through here, you've got the mountain ranges. No, I can't see. But yeah, basically there's the mountain here, and that goes all the way up Australia. So anything west of here is just like desert. And New South Wales is huge, right? Like from here to here is like 10, 12 hours driving. So, yeah, and you know, everybody's in Sydney. So there's like 5-point-something million people here. And then in Australia, there's like 25 million. So, you know, if 5-point-something million are here, then yeah. But it rains quite a lot, yeah. It's especially recently in the past like 10 years, it's fucking hell, it's like tropical. Yeah, it's crazy. But, you know, we've got like little waterfalls around here and stuff like that. Wow. Tasga hadn't ran for 4 months. Yeah, wow, that's surprising, especially like. Oh well, I guess it is maybe that like wet dry thing. 90 degrees. 90 degrees everyday tropical desert. Ah, yeah, that dry tropics. Yeah, yeah. Like if you look at where is it? The climate. Where's oh they've changed it. Okay, so you need to do this. Where's that? You know that table? Yeah, I know that, but I want the table. Where is that? There we go. Oh, it's so big. Okay, there we go. See what we're working with here. Yeah, but the rainfall has been way higher. Like we had, yeah, I'm surprised that it's only this because we had like 100 mil fall like a few days ago, just in one night, 130 mil or something. So yeah, I guess this is, yeah, 1991 to 2020. Oh yeah, okay, so yeah. You can sort of see the dry and the wet a little bit. $32. There's the that's what I wanted. Fucking hell. There we go. So it doesn't get super hot, but it can feel hot, right? Because of the humidity, so yeah. Humid subtropical climate, yeah. Okay. $32C, yeah, wow, yeah. Yeah, we got dry tropics up in, how far? Oh, Savannah, wow. Oh, the Savannah, wow, that's weird. Rainforest over there. Humid subtropical, yeah, so same as Sydney. Monsoon, yeah, wow, okay, so that's, yeah, I guess it makes sense further south. Oh, Everglades, yeah, of course. Yeah, makes sense, yeah. Yeah, it's absolutely, yeah. Yeah, it is both, yeah, it's exactly, yeah. Thanks to mannerisms. I don't hear any. Yeah, you said you're from Oregon or so? Oh, so, okay, well, there you go. Ah, that was what you were saying. Yeah, okay, gotcha, yeah. Go to, oh no, this is the packetized elementary stream. That's so, I just don't quite get that, but anyway. Header is immediately followed by video start code or audio sync word. Okay, that makes sense. I'm reading, by the way. I'm reading this stuff as I'm going. Even then, it's a social aspect. Interesting. Yeah, right. But it's an open air mental site. Really? Wow. Fucking hell. Yeah. Wow. Stay east of the Mississippi with USA. So New York County has the same. Okay, this is a to-do here because we also have the yeah, I don't really want to have that there, but yeah. Okay. That is looking a lot better. So let's have a look at our documentation. Pairs. Okay, data contains the raw video, audio, looks good. Okay. All right, that's looking, oh yeah, maybe that's the, we should document that block. Oh, the gob, yeah, that is interesting, yeah. Yeah, gobs is interesting, and that's in the, another one that I haven't really seen used a lot is the, RPC, this one. Super interesting. I just never, haven't seen it used ever really. I use JSON RPC. Oh yeah, nice. That's down here, isn't it? Yeah. Oh, it's actual JSON RPC. Oh, yeah, the actual spec. Yeah. I forgot about that JSON RPC. Like that it's like an actual thing, not just a custom. Yeah. Oh, God, my fucking neck, man. You sick bastard. Oh, fuck. I wanted to do the... let's get that. Just document that const block. When you do the... fields, where is that? Fields. There we go. Do you document at the bottom or at the top? I feel like it's actually at the bottom. Oh no, it is at the top. Yeah. Yeah, top then. Yeah. Oh, look, I'm happy just with that for now because it's like, you know, these things are just never, like trick mode, like they're just never even used. Okay, cool. So, that's good. That's good. Okay, I'm happy to commit. What's in there? Oh, it's just that, isn't it? And then to start, I don't think we're reading that. I'm not actually. Yep. Okay, here we go. Okay, whew, lot of code there. Almost 500 lines, damn. Alrighty, so next up is yeah. So what have we done here? We've done all that, and that. So that's cool. Document. Oh yeah, we've done that too. Okay. Oh, now we need to wire up. Okay. So now we're going to use MPEG-TS in HLS serve. That's the next job. That's going to actually involve, you know, we're going to need to create a like MPEG-TS. I'm going to call it a scanner. Okay. So how this works right now here is right here. So we'll sort of just arbitrarily say, hey, like every sort of so often we reset. What's that? Oh yeah, the buffer. Yeah, yeah. Yeah. So what's happening is that we're just copying this many packets into a buffer, and then at some point in time, I think we've set it as every 4 seconds, we just say, okay, now flush that to disk so that it can be served over HTTP. And then we just go round and round and round and round, which is cool. Like, it actually works. I mean, if people are actually watching the stream, which I'll link, right, something like that. Oh no, not that window, it's this one in it. There we go. Yeah, so that'll actually hopefully if I load it up for myself. Come on, baby. Alright, yeah. Oh, there we go. Yeah, we got it. Okay, woo. Okay. Yeah, so that actually works. Fun. Alrighty. So what we'll do is that instead of doing it like this, what might be fun is to actually, from the reader, actually decode and encode the packets. So let's, and really what I'm thinking about is something that looks similar to the buffer.scanner. Something that looks like this sort of interface. And this is the one where you can kind of go, you know, you do scanner is a buffer.new scanner, and you get a reader. And then you do like this for scan, and then you just process your, you know, you process your content. So you can go like line is, and the scanner maintains its own buffer. And it's also got this sort of handy way of reporting errors. So essentially when this thing stops, you know, when this thing returns false, then you can go if sc.err does not equal nil, then you can handle your errors. So yeah, that's basically it. Yeah, let's now I actually wonder if we can just like use this thing anyway. How the scanner works is you give it a more control of error handling a large circuits, buffer a reader. Yeah, like we can use a how do we define the split function again? Oh, the split, that's it. So scan dot split. It seems like it buffers a lot before playing. If you move the player back head close to the end, it gets choppy. I assume it's the size of each playlist file. Yeah, and also it's the way that we actually split the video is not super, like, not very sophisticated. Which we could actually make better by using this MPEG transport stream package. So what we could do is actually like parse the packet and go, okay, is it a good time to stop or not? And then we could do something like actually set the discontinuity flag in the header. And then that'll kind of like help the player along the way. The other thing that we'd want to do though is, did I ever get it loading in a web player? Yeah, I think so, yeah. Yeah, it loads up in, yeah, I think so. There were some cause headers and stuff like that, but yeah. Yeah, the HLS.js, yeah. Yeah, that one, yeah, pretty sure it works. Though I can't remember, to be honest. That would be a good, I actually have that down. I think I've written that in an issue, is to like have some sort of, like a sort of little command that tests it with those players. Rather, sorry, not with those players, but yeah, actually I can't remember. Oh, my fucking neck. Oh, my shoulder, really, it's my shoulder. Let me take this off. Oh, okay. Yeah, there's that. Yeah. Yeah, that's true. Yeah, but then, yeah, actually maybe what we should, yeah, but I think what you're saying would also be really, what you're saying is also really good as well, that we like check that what we're writing out actually makes sense and have a way to test that with like, yeah, a bunch of different players. I think what we can actually do is write a scanner that, or rather write a split function that the built-in scanner can use, and then good night. Thanks for stopping by. Best of luck waking up. Lights. Cold now. Jesus. Alright, I'll put this back on. So let's write a split function so that we can use this built-in scanner, because that'll be really handy. So we can just do it here, and then we could probably put it into the into our MPEG transport stream package afterwards as well. All right, let's go. So what is our split func? Used to tokenize the input. All right, let's give this a go. Split. Packet. I feel like this isn't quite gonna do what we want, because like we're still gonna yeah, I'm just thinking how to do it. So we could do it in a way that that the nah, okay, let's just do our own little scanner, just because I don't like the feel of it doing it like that. We can do it. Let's actually do it in the MPEG transport stream package, and then we can just test it and run it and see how it goes. We could even benchmark it against the existing implementation, but anyway. Okay, so this is type scanner. So what we're doing here is that we're just like getting the is error. I'll do maybe, so I'm going to do is a new scanner from reader, and that'll return us a scanner. I'll go, the RD is actually going to be a buffer.new what is it, buffer.reader, what is it, go.reader, and then we're going to give it a buffer of 188 bytes. New reader size, maybe that's it. Alternatively, we could actually just have this, a buffer, and it's just a slice of bytes. And not only a slice of bytes, I mean, we could actually just have that as a fixed, like, yeah, I don't know. Yeah. So we could just make that like that, and then actually the capacity is also going to be that, because we know we're not going to be dealing with any more than that. Packet is nil. RD is going to be the reader that we're going to be reading from is just the reader. Packet is nil, error is also nil. So let's try that. Okay, SC, scanner. Okay, so scan returns a boolean. So what this does is that this advances advances our scanner to the next packet. So in this case, what we want to do is actually like read in 188 bytes from the reader, store that in the buffer, and then return true if we're all good, but then return false if we've got an error. If we've got an error, we need to store the error that we got so that it can be accessed. So what I mean by this is that let's just do the important stuff first, which is always error handling, right? Error. And all this does is it returns sc dot like that. So let's read from the reader. Oh no, okay, so endless and packet size, so we're going to go we're going to store it equals otherwise the error here is going to be something that return false. Okay. Otherwise, if not equal nil, I will. If errors is top. And n equals packet size, then we're good. I'll return false, but there's no error because we've read exactly enough packets. We've read exactly enough bytes to fit a packet, and we're good to go. Yeah, seems all right. We probably want to zero out the buffer as well here. So we're going to go buff, right? Like we need to, yeah. Is that the, I can't remember how you zero it out now. Zero, is that it? There's a special thing, I always forget the notation for that. I think in the latest version of Go, they've actually introduced a new built-in function to handle that for us, but anyway, yeah. Oh, sorry, it's Mr. Chubby. Hey there, Griot, G, right? Is there a page that explains the whole project in depth? Not too familiar with Go, but I'm thinking this is developing a Go backend for a streaming platform similar to Twitch, but low level. Yeah, look, really, this is, it kind of is really just what it looks like, which is really just a collection of libraries that we're developing just to learn about like video and audio protocols, streaming, networking, practice software engineering, and yeah, I guess that really is it. So as we go, we're just kind of picking a new part of the yeah, we're kind of picking like a new component of what you'll generally find in like in a sort of video streaming or like audio streaming sort of setup. And this isn't just like Twitch. This is the same for like even like digital radio and stuff like that. You'll find all of these parts. Yeah. So that's really the idea. I think there are no real there's no applications yet, apart from the fact that we happen to be like we're using the package. We're using some of the packages that we've written to self-host this stream. So of course we're sending this stream to Twitch and to YouTube, but we also have our own tiny little, very bad, like stream that's accessible via HLS. And yeah, that's that's pretty much it. So that link to the stream is actually in the little, whoops, which way am I pointing? It's down here somewhere. Yeah. Maybe we can just check here. No, I mean, we just return true. Right? Oh, maybe no, we should do the checking, and then finally, if we're really happy, then we can return. Let's do another check here. So we want to check if we've got oh no, we're already checking that. Well, actually, if we've got EOF and we actually read the, then we're just happy to return true. Oh no, sorry, return false, but without any. Oh no. What are we looking at here? Errors. And then really under any other circumstances, and then, yeah, that's it. Because if we get a nil error, then we just stop scanning. I guess that's the rule that we're going for. Okay, let's implement the packet decoding. This will return an error. Yeah, let's do that. Okay, so decode the packet from the buffer. Not equal nil, return that, and then okay, decode packet. And we got that error. Otherwise, we can store the packet as well. So packet equals p, and then we would also return p. This is so that we can keep getting it afterwards. I just want to have a function that like now operates on 188 bytes, like without allocating a new buffer every time. So that decode function, I mean, yeah, like that works, but yeah, we really just want to pass like a pointer to a buffer, a pointer like to a bytes, to an array of bytes, which is what a slice is for. So we need a function that operates on a slice rather than an IO reader. In a sense, this is the kind of streaming interface that we want. As in, like, this is the interface that's going to operate on an IO reader. This logic, I guess. Okay, so let's try that. Oh, let's see that. Yeah, this really needs to be like a, you know, like a, let's do an unexported function or something like that. Let's refactor that a bit. TS. Codec. One like an unmarshaled, really. So what's the order that it goes in again? Yeah, this is going to be the byte, and then the P is pointer to a packet. And this is just going to return an error. And then we know that if that does not equal packet size, then we know we got to, yeah. Have, and then enough data. Okay, then we're going to do this whole thing. So yeah, I mean, this is really going to be the, let's call this buff. Just because it's the same, although not really a buffer, but anyway, we'll call it that. Now we can go down and just grab pretty much all of that, and yeah. Put that into here. We've already got P. I think that should be it. There we go. And then here we just go return the unmarshal, right? And then just exactly the same. Let's give it a var packet. No, wait. No. Hold on. So var packet, and then we go. That. I think that's about right. Oh no, data. Oh, that's again buff. Probably a few returns. Oh, and just one, is it? Oh yeah. Cool. Okay, that's nice. Nice little refactor. Okay, now we can just go and instead of doing it like that, we're going to go var p packet. I think, do we want to allocate a 0 one, or can we just reuse? No, we're gonna have to reuse. We're gonna have to allocate a new one, which is fine. So we do something like, you know, p equals new packet. Marshall P. Just do a Marshall really. Yeah, I think that's it. Now, just write a little test just to make sure everything works. So we got that test. We can just do the same thing, but maybe like test scan or something. Reading from the reader F, which is now in our case just a file. Now we go for sc.scan. Okay, here we go. Packet is c.packet on a packet. I feel like maybe in the scanning function we should actually actually, in the scanning function, we're going to try and decode the packet too. Yeah, that's better. Because then we've got exactly the same interface as the one in the standard library, which is good. So it sort of feels the same. So let's do that. So we've got our scanner. So we've set really it's in here that we can try. The point, we're going to have to do allocate a new one. Oh. Yeah, no, we're going to have to allocate a new one. Okay, and then we go. Okay, we're going to store the error that we get. Equals Marshall. And then we return false because we couldn't scan. Otherwise, we're good. And then we store the packet as well that we got. So sc.packet equals p, right? Yeah. And then this just return the point to the packet. Just return sc.packet. Pretty easy. Let's do that up here. Oh, fuck. On Marshall. Great. Alrighty, so what do we got in here now? That's our test. Oh yeah, okay, so now let's finish writing our test out. So let's get this and just put this over here. Okay, for sc.scan. Sc.packet, like that. And then what do we do with it? We could try write it out, or do the same sort of test that we had up top here. So just try and get the bytes, but it's not, I mean, all of that is the same, so. Okay, what we could actually do is like try and checksum the whole thing. So, and then we could just do like a really easy check. So what we could do here is actually just, yeah, like get a like a MD5 sum or something, right? MD5 is fine for this case, so. Do it again from a new sum of the data. Okay, yeah. There's always 16. Okay. Cool. Okay. Let's just read it into a big fat file, a big fat slice. It's only 800K, so I mean, yeah, whatever. This isn't, you know, this isn't used in like, I mean, this is just for testing, so it's fine. Okay. Oh yeah, okay, again. So let's just do that. Yeah. And then we'll write it into a buffer that's going to be blah 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 buff. Yeah, okay, and then we'll just go encode into there from our packet. So encode the packet into that thing, and then if it's c.fatal really. Keep going, right? So then if I see nil, there we go. Alright, and then now we can go sum2 is, oh, we can just go if sums if md5 dots sum the get a MD5, get the checksum of the bytes in our buffer, which is like the whole file that we've encoded, and then we can just do a direct comparison. Does not equal the sum. Then we can just do an error. re-encoded stream differs from source. So MD5 of okay, does we have to use X, I guess, probably the clearest. Yeah. Okay. So we got MD5.sum of okay. See if that works. Okay. Nil error. Oh, whoops, sc.error, yeah. That's the error. EOF. Oh, okay, well, that's okay. Shouldn't be a big deal. This one is going to be if n is 0, right? So if we get an EOF and we read 0 bytes, which is fine, then we can just return false. That's not an error for us. Otherwise, if we get some other error that's not EOF, like, you know, broken pipe or whatever, you know, network connection or anything, timeout. Now, then we store the error and return false. Otherwise, we don't, you know, we've got no problem. Fuck. What's happening there? Is it 0? Is it N64? Am I going here? Uh-oh. Not there. Yeah. There. Oh, we're doing, yeah, look, we're doing, if n is less than packet size, which is fine, so io.eof and n is 0, then we're happy to just, we're done. I'm not so happy with that error because there could also be there could be some useful diagnostic information in that error. So I want to kind of use that. But if it's nil and we still read less than that, then I don't know what's going there, but I don't know if that's even possible, but yeah, let's just write the code anyway. So if I don't know, something like that. Then we've got a nil error, so who knows what. And then, yeah. Yeah, and then that's it, I think. Okay, cool. Oh, fuck me. Holy shit, that actually worked. And we got the checksum right, apparently. Maybe. Shit. Oh yeah, that's okay. Let's just run that one test. Oh, no. We can run the whole thing, doesn't matter. Let's just... Hey, good morning. How you going? Good morning, good evening. I can't believe that fucking works. It's just like, how did that work so quickly? Oh, yeah. Okay, and then... the sum? Fuck me. Okay, well, that's fine. That works. I mean, I've written... Holy shit. First try Thursdays. Finally some success after yesterday. Holy fuck, that was a fuck up yesterday. But today seems to be going just fine. Yeah. Oh shit. Okay. Well, look. I mean, wow. That's cool. So that definitely should have an example function, because that's really like the... You know, that's like the real deal way to sort of read an MPEG transport stream using this scanner. So, oh, goddamn. Okay, I'm gonna get some tea. Oh, and then, hey, yeah, and good night. Yes, yeah, just about. Sort of good. What are we? It's 5:20 here, so yeah. Oh shit, I really fucked my shoulder, I don't know how. Okay, great, yeah, alright, I'm just gonna go for a quick, quick break. Get tea and, yeah. I think so. The chair is very bad. Yeah, and even, I think I don't know, I'm just, yeah. And to stand, but then to move around, right? Not just to stand statically, but yeah, to kind of move a bit more, yeah. That's why I'm getting up now as well, because it actually really hurts. Okay. Be back in about 5-10 minutes. I'll just... Okay. Oh, is that... There. So dark, man. This there we go. That should be better. There we go. Okay, here, here. Oh, there, okay. Actually, I'm just going to do that for now. Alrighty, so let's go. That, let's do that, that. So we have a scanner now, and yeah, that's cool. So let's say what we want next is to use that in our, okay, I do want that back, maybe, in our HLS serve command. Let's go 308, HLS serve. Okay, there's our reader. Segments. So instead, what we're going to have is a no, not buffer. It's going to be MPEG-TS.new scanner from the reader. And then while that's going, we're going to go if scan. And then we've got a packet, so let's write the packet to our buffer into our segments. So this is going to replace that line. So code into segments P. If that's, then we need to do do something like that. So that's len of segments, or no, len of just encode packaging, that's fine. And then there. Otherwise, yeah, otherwise, so this is sort of saying like, hey, like read in some bytes. No, what this is saying is scan the next packet from the input. And the scanner's input is what we're passed in R here. Now we can just check for errors from the actual scanner. So we just do scan, and then just scan, program of scan. Just scan is fine. There. So that's yeah. I think that's it. in this thing, we could actually say which segment that we got up to. That might be a good bit of context. So segment, so that's segment. Yeah. Yeah, I think right. Yeah, right. Yeah, absolutely. Yeah. Or right. Yeah, right. Segments. Segments is good because it's sort of saying like, hey, like we're not just writing the stream, we're actually like getting a segment, writing it, getting a segment, writing it. So a little bit, yeah. Although this isn't great code, I wouldn't call it this, yeah. Like the way it's sort of write segments, and I'd probably have a, yeah. But it is a good point, yeah. MPEG-TS. So again, let's give it some context. Segment. Yeah, no, totally. Yeah, I mean, yeah. Error. Oh no, that's sc. Yeah, is that? I mean, that's sort of okay. I mean, obviously got this sort of shit, so yeah. And they're returning nil. Okay. Now we can just quickly test it by doing something, I don't know what. We could read in Big Buck Bunny and yeah, and then try and play it back. Now, how does this thing actually get its input again? Oh, TCP. Okay. What I'll do is I can just kill our own HLS stream and then yeah, send it to this computer, and then we should be able to serve it. So let's see what that looks like. Oh no, am I going to run into the same problem where like I can't? Yeah, I can't edit the recording as the since we're already like actually streaming. So I'll think of something else. Yeah, okay, I got an idea. Let's run this. Or not. Let's not run it. Oh yeah, the packet in the scanner's buffer, so that's the scanner.packet. Not equal nil. Alright, so now we've got our HLS serve listening on TCP, port 9000. So now what we can do is read from Big Buck Bunny. I think we can do it FFmpeg. But let's just see. So test. Wait. Let's do 480p. Okay. I think. Let's see. So ffmpeg input is that. We're going to do it real time, so that's -RE. And because we're sort of simulating like a live stream, otherwise it'll just try and read in like as many bytes as it can and send off as many bytes as it can. And then what are we going to do? So then we're going to send it out to MPEG transport stream. We'll just copy whatever codec we've got, and then we'll send that to TCP, our local host. So 1 port 9000. I think that should be it. Oh, the RE has to come before the I. Okay, yeah, all right. Let's get that right. Okay, there's our command. Let's try that one. No. Connection refused. Interesting. So I guess maybe it's just doing IPv4. I can't understand that, but whatever. Oh, yeah. Oh yeah, it looks good. Okay, now if we MPV 8080 was it or something? 8000. Okay, playlist. Whoops. Sweet. There we go. Okay, there we go. There's our test. That's good. That's good. It's good. So we're reading in like real world data and it's freaking out. Decode PES packet, decode header, short buffer, header reports 206 have 175. Huh. Interesting. Let's get rid of that top media thing. Segment 4. Interesting. So a way to iterate on this more quickly would be to is it close enough? Yeah, that's like, what the fuck is that? I mean, is there some have 175? Are we? I don't understand how it can be 206. I mean, but yeah. I mean, I can see how, but I didn't think that may, yeah, I mean, that's definitely our bug. So we'll go into, what I feel like I want to do is actually just save this to a file. And then we can just run some tests on it ourselves. We have a little command called tspipe. So let's actually re-implement that to use the scanner, just because. I mean, we don't even need to, yeah, we don't even need to bother. So let's open up PES and let's do this, go run cmd-ts pipe. Let's just save that to a file just because it's quicker. There we go, that should be it. Yep. Oh, we don't need to do it real time. Now we can actually write as fast as we want. Go. Now it'll just dump it down as quickly as possible. Okay. In the meantime, let's set up our command. So we're going to read from bitfields.ts and then we're going to write it to, let's just write it to dev null because there we go. Okay. I can actually probably do that right now. Yeah. There we go. Oh, there we go. Look at that. Interesting errors. And then of course we're getting a short read because like the thing is still being written, so it's fine. Alright, unmarshaled payload, decode PES packet, decode header. Okay, so there's our error that we had. And helpful, we've got a thing there. Packet number. Okay. Decode PES packet. Short buffer. Okay. First up, this is invalid because the yeah, this isn't actually right because what we're doing is the length that's reported. Okay, no, I need to. Let me think about it before I start talking smack. Can we possibly have 206? Because to have 206 would mean that like that isn't 188 bytes. How could we have gotten 200? Oh well, no, sorry, no. It's reporting 200 plus bytes. Let's run it. Reports 206 have 175. Let's see what Wireshark has to say about it. So we'll go to packet 10378 and see. Interesting. I'm just doing this just to like program stream. What? How did it get that? Oh, it's just a pairs. Okay, well. Yeah, okay, whatever. Nothing unusual. Where are we going again? 10, 3, 7, 8. There. Okay. Decode pairs packet. Okay, here's our pairs. Header data length. Oh, there we go. Okay, so it. Something wrong there. Header reports 206, have 175. Hey, yeah, sure. So, essentially, all that we have, there almost is no project. So what I mean by that is that we are writing, really just developing libraries that are used in sort of media and broadcast systems. So, or that, yeah. So we've got one for HLS, HTTP live streaming. So if you're watching on Twitch, which you are, that uses HTTP, that uses HLS to view video, play video. We've done a library for SCUDdy35. So that is a messaging standard that is used to signal breaks in MPEG streams. Like ad breaks or like, you know, breaking news or something like that. And then right now we're doing MPEG transport stream, which is used also in, well, it's a media container format. So it's sort of like MP4 or MKV or WebM on YouTube. MPEG transport stream is also used if you're watching on Twitch. It's a container format that's sort of been designed for use in for streaming media, as opposed to like something where you know the beginning and end of it. So it's used actually in digital TV and radio, stuff like that. So yeah, essentially we're just writing libraries that can understand these things. And then along the way, we're just kind of like developing little tools and just learning about like software development, learning about how, you know, streaming and these sort of protocols and sort of messages work at a low level. And we're doing it without dependencies and all that sort of thing. Just using the Go standard library. And it's working okay so far, I guess. Yeah, but hope that makes sense. Yeah, oh yeah. Yeah, it's fun. It's fun. And it's a good, yeah. Yeah, just, you know, chunk by chunk, really. And I think next we'll do RTP, or the real-time transport protocol. So that's one that's used in, you know, like voice calls and stuff like that. So, you know, when you do FaceTime audio or like WhatsApp or whatever, that I'm pretty sure, I know FaceTime does use RTP under the hood. I assume WhatsApp does as well. Yeah, it's a way of like doing low latency audio, video sort of transport using IP, as opposed to like, you know, a headphone cable or something. Or HDMI, or there's one called SDI, or, you know, coax or radio waves or something. Yeah. Yeah, no, it's good fun. Ten, 3, 7, 8. So in here we're reading the PES packet. I like to call it real programming. Yeah, well, look, it's interesting that you use the word real. I gave a talk at the Go programming language meetup in Sydney a few weeks ago, and I re-recorded the talk and put it onto YouTube because my internet connection stuffed up when I was recording it. Yeah, and I think it's real programming in the sense that I think so much of what we see is just like web development, and sometimes, of course, web development is real, right? I mean, like that's you know, can be that's like super hard. I find web dev really hard. But part of what's so hard about it is that the stuff that you're trying to represent, so your data structures, your you know, all your algorithms, your like the way that you separate components and stuff like that, it is so abstract, because often what you're doing is just like modeling like random business processes. So when you're doing something like this, yeah, like in a sense it is real programming, because and it's real programming. The word real is kind of interesting because it's like, hey, like this is actually like a real world, like actual devices use this thing, like real devices that people use. Yeah, and for me that's easier to understand. So when I read this, I kind of go, oh yeah, okay, like the priority means that it actually needs to be, you know, like it actually means something. It's not like priority like, oh, somebody thinks it's important. It's like, well, can you measure that with a Boolean? How important do they think it is? You know what I mean? It's like, yeah. Yeah, I see. Yeah, and look, and yeah, the dependency thing is getting crazy, huh? Right? I mean, you know, yeah, there's a lot of yeah, I mean, the library, external third-party library thing has gotten pretty out of hand. Yeah, I don't think we, yeah. Yeah, I mean, obviously G10, XZ, right? I mean, that's the latest one, but I mean, you know, like, just in general, right? Like, it's crazy. Crazy world out there. Yeah. Yeah, it's cool, yeah. Thanks for saying hi. Yeah, yeah, it is. Yeah, it is. Like it's really, yeah, Yeah. No, I agree. I personally found it quite difficult. Yeah, I've done Java. I've done like front end web dev. React. And yeah, it's weird. Yeah, I'm not quite sure what's going on there. The framework thing is tricky, yeah. Because like you learn this thing and then it just kind of goes away, and you've learned the framework, but then you don't. Then there's a new framework, and then you don't like you still haven't learned that much because you just go on to the next thing, and the next thing has nothing to do with the old thing. So it's kind of like, I don't know. That'll be it there, I guess. Packet 10378. There's no way the header's saying 206. There's got to be something wrong there. Is there another way to get a length? Once we're here, maybe let's... Oops. We decoded the header, or we tried to. We got to here, and we've got 20. So this value right here is 206. It's crazy. Okay, let's what we can do is see what the value of the flags and fields are here. By 31 error. I know, that's the problem. It's something not like, yeah. But the thing is that when I look at it in Wireshark, I think the value I want in here should be 5. So what I'm going to do is just like print the stuff leading up to it and see if we're just getting like total gobbledygook or not. Hey, how's it going? Dude. Something like that, I guess. I mean, let's just do that. See that. Huh? Decode header. What? Oh, I'm piping to dev now. Whoopsies. F oops, fuck me. Okay. What? Okay. Some nice printf debugging here. Oh, that's good. That's good. Okay, there we go. Okay, so those are the flags that are set. So now we can check Wireshark and see if it matches up. So these are the flags in the PES header. So if we go into here, we go into the here. Okay, we got 1. Yep. 0, 0, 0, 0, 0, 0. Wait, are the flags just 1 byte? Yep. Okay, 0. Oh yeah, okay. Right, so straight away that's we've got we've got some, we're not lining things up well. Because what's happening here is that like in the fields, so that these are the fields. Fields should only be 1, and we've got like 0, 1, 1, blah 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 blah. So we're fucking way off. So whatever we're passing into here is not, you know, it's not the right thing. So I guess we'll leave that there for now. Let's decode PES header. Let's see what's going on here. We can check the ID. Length is 2874. Let's grab that. Somehow. Oh, here, let's just print the yeah, it could do T-Shark, yeah. I don't know how much. Yeah. And then put it into here. Even like hex dump. Here we go, look at this. See, and we're definitely, right, like the ID. So apparently the ID is, so the PES stream ID. OXCO. What's OXCO in real money? Will does TCP dump, does that actually read the,
Whoa, seriously? Hold up, yeah. I thought I only read Pico files. Bad dumb file format, yeah. What about, woohoo! No way. Part of the problem with MPEG transport stream is the overhead. Like there really is like a lot of overhead when you're talking about like, when you're sending out a lot of video and stuff, there's like, there's a shitload of packets. Because every single packet has to have the, all of this stuff. And it has to be 188 bytes. So if you imagine like a video, like a high def or high bitrate video, there's loads of packets. So it was sort of, when there was relatively less payload, it wasn't such a big deal. But, now that we've got these huge, like large files basically with a lot of payload, quite a bit of overhead. Especially, remember, like, often what I always think about is like, all these fancy codecs, like, they're not really there to like say, they're not really there to help people like us. They're meant to help like the massive companies that are paying fucking huge CDN bills, right? That's why they come up with these fancy codecs, is to save money on bandwidth costs. No, that's cynical, right? But it's sort of an interesting way of thinking about it. Okay, it's going down. I'm killing the shark. What I'll do is, yeah. I just 10.384. Nah, the length is totally off here. So I think even what we're... The length is totally different as well. So let's go up to... Let's check where we're decoding the pairs, maybe? Oh, there we go, that's better. Codec. Is this sophisticated enough? Yeah. So what it does is it looks for this prefix. So these are like the marker bits, it calls it. Or marker bytes or something, yeah. But it's not very convincing, is it? Now the thing is that when we read, I mean, the packet at 10.378 let's look for the marker bits in here. And there should be, you know, like, I say there should be, but maybe not. To me, I don't fucking see them. So we got the header. And, oh no, they're there. Yeah, see 000001. Okay? Yeah, so that's, yeah. So it's got that. And then, yeah. So in here, oh no, there, that's it. See, 000001, and then it you know, it reassembles it because it's spread across like multiple. The actual PES packet is spread across multiple MPEG transfer stream packets. There's this weird sort of thing, okay, encapsulated. C0, what's that in real money? And watching while taking care of a Spark signature machine. Action is now sipping his first coffee and watching while taking care of a Spark 64 machine throwing build errors. Yeah. Nice. Wait, let me just see what that actually means, because is me. Oh, yeah, gotcha. Yeah, is me on IC. Yeah. You should speak to what's his? I can't remember, the Last Miles. You know, he's always he's always banging on about some PowerPC thing. Yeah. It's good, isn't it? Bloody hell. What's up with that crazy server that he has? I'm too busy before to ask about it. They had some huge, like the like 512 gig of memory and stuff like that. Decode pairs. Fuck, I mean, that's so weird. Like OX, and that's C0. Yeah, so we got that, and then the payload. Is that, have we got that right? The stream control. Oh no, no, there's that. No, sorry, no, those aren't the marker bits. Okay, so your stream ID is 1 byte. Yeah, OXC 0. Let's do that. $192. So even that. Zero, 1, 2, and 3, yeah. Look at that. That's totally off. Packet 10378. That's like we're not getting some different value. $111. I just don't get it. Like maybe oh fuck. I mean, I'm not sure how to debug this. Like apart from I mean, yeah, I can think of ways, but it's quite interesting. It's like, okay, you know what? How does this work? Alright, I was just thinking if there was something weird in the actual command, like if we were doing some kind of like race condition or something, I don't know, just something really bizarre. Instead of doing this, we could actually find exactly the packet that we're up to in Wireshark and then go from there. Let's just see. Sorry, I was just deep. Oh, yeah. Don't know much about it. Can you please? What should I read? Oh, I don't know. You mean about video streaming? I mean, I think a really good a really good introduction to it is video. Here we go. I think this is always a good one. That's just like a good overview of like how these sort of streaming things generally are put together. Testing grade, yeah, gotcha, yeah. Doesn't honestly blast away for Dennis. Oh, cool, okay. Yeah, I will do. Let me just write that down. So on Libera, yeah. Oh, was it Blast Wave? And I have. Cool. Yeah, will do. Yeah. Oh, oh yeah. Hey, good morning. Hey, how you going? Good morning. Good evening. What bugs do you actually get? Yeah. That's yeah. Good idea. Good idea. No worries. Yeah, that's that's a good article. And then if you've got any other questions or like if you're interested in anything really, like just reach out or there's a mailing list link here. So if you've ever got any questions or something, just write there. You don't need an account or anything, but yeah. Do you have any? Nice to catch you live. Oh yeah, no worries. Yeah, hey. Okay. Yeah, let's yeah, let's do that, and then let's go. Okay. So, how I got viral? Oh yeah, yeah. I hope people weren't taking the viral thing seriously, right? I mean, like that was the joke, right? Was because despite trying to avoid anything to do with clickbait and all this sort of thing, it something that the clickbait gets you in the end, sort of thing. But anyway, yeah. Okay, so what do we got here? Is this what? Oh, okay, hold up. Let me exit. So when we write it out. Yeah, it is. It's a good time. Yeah, it's the best time. If we get an error, decode. Okay, when we encode one, let's fatal. Okay, and then we'll just do it again. Yeah. Oh no, that's decoding a packet. So let's do that. All right. And then now let's see exactly where we got up to. Okay. So we've got that one. Let's open up, I'll just close that and then that. Okay, here we go. 10.377. So these are the bytes leading up. So this is, let me arrange this. So this is, on the left is our known good transport stream, our stream, and then on the right is our busted one. So for whatever reason, we're not decoding this one correctly, which is very strange. One, and then this should be, oh, 0. Yeah, okay, so let's read this one. Adaptation field payload. Okay, so that means there's only a payload. So we can't decode this thing. Oh, whoops. Uh-oh. Okay, let's fix it up. Let's just do that. Oh, it's HTTPS. Oopsies. Yeah, okay, my bad. Okay, so I'll just do 45A. Oops. What is it? Block return, blah, 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 blah. Okay, so block return that. Yeah. Give me more. There we go. Detach Sam, yeah. Cool. No, thank you. That's yeah. So what we're getting here, 000111, it's a continuity counter. One. Adaptation field. Unmarshal payload. Okay, whatever. Into the packet, okay. The adaptation field, so I keep saying this, I need to turn this into constants, but what this is saying is that there's only payload. These ones are saying there's adaptation field and then payload. Well, actually, no, this one's saying that, yeah, anyway, yep. So it's weird, yeah, it's like, so in this case, we know that it's only payload, so the packet, so we're gonna do that. Oh, fuck, we're off by 1. Oh, no, that's 4 plus. That's that, yeah, okay, so it's not that. Let's have a look. Let's go back. No, all we've got is payload. Payload data. Oh, this is it. This is it. This is it. That. It's that thing. Okay, so only present if the payload unit start indicator flag is set. And the packet data type is PSI, not PES. What? Okay, maybe not, but still, that's very interesting. So let's have a look. So in our case, what we'd see is payload unit start indicator is not set. Okay. Okay, oh, well, it's not that. Okay, my bad. Got excited. Too excited. So if we read that packet, adaptation field, control, continuity. What I should really do is like try and just grab these bytes, like grab this specific packet and just test this one. So let's do that. Let's save, export. There was a thing we did yesterday. I can't remember now how. Export the packet bytes, was it? Yeah, that was it. Okay. Let's do that, and then let's just add it to our tests. Why not? Test decode. Let's get. We've got that test already, so. Okay, it's just for now, right? Where is it? Okay. Now we can really start to fuck around with it. Let's get rid of that. And we'll keep that there for now. Let's get our whatever. There it is. Funk, not fucking. What? Okay. Famous also. Okay, there we go. And just let's, oh no, sorry. Yeah. Test with pack. All right, there we go. Now we can start to screw with it. Doing here the decode. The packet size. Marshall. Let's dump the payload here. Oh, the header. Can I do... Yeah. But I need to like do a hex dump or something, right? I don't know if have I got that installed? There we go, cool. Ooh. So there's our sync byte. No, wait. Why does this look... Oh, sorry. unmarshal payload. What? I thought we're not P. We're filling it out. Oh, right, yeah, okay, short read, yeah, blah, blah, blah. Return. Let's do that. Let me just see how to interpret this. 01, 47, where's that 01 from? 47, 01, 01, 11. 47, 01. Oh, it's bloody, yeah, I need to swap it around, don't I? I want it big Indian. Oh, -C. Okay. Yeah. Yeah, this is the one. This is actually in, this is what Wireshark, what do you call it? Yeah, this is what Wireshark actually calls, isn't it, under the hood? Nice. Ooh, all right. Yeah, cool. That's a good one. Thanks for that. Okay. On our own, 1-1. So we're reading along. And then we get to 6F. So when we are unmarshalling the payload, we're checking the 3 bytes, and we actually get that. So we get the, so we need to go into here now. Whoa. So when we go into PES, the decode here. So we're reading the ID from here. So that's the stream ID. So that's saying like, oh, this is a, you know, whatever. Because bytes index 0, 1, and 2, we don't care about. That's handled by there. So then we're saying, oh, there's no PES packet, something. And then we go and reread the length. Which is here. And then we read the up here. Well, let's check. So we're doing pairs. Let's check. So stream ID is 1 byte. The length is 2 bytes. So that's 4 and 5. And then we pass that over, like we pass the remaining bytes into the pairs header. So 7. I don't know. I don't think so. I mean, yeah, like that would be from. That could almost go, and we could just have it here, like buff, you know, just something like this. Something like that. But, yeah, because we always, yeah. It's probably almost clearer, I don't know, yeah. Oh no, that's actually wrong. I need to do, just let me do it like that. Okay. Then we equal nil header. I feel like this is, it's just weird. Like, so we read the length, right, from those. So what is the length? Like, let's print that out. Oh no, we know what it is. It's gonna be up here. Oh well, no, we don't actually. Let's print it out though. Pairs is nil. Yeah, okay, because we're not returning it. Let's do it there. Okay. Okay, this is 16199. So is that value? Let's actually try it. So let's get this thing and just go binary.big Indian.uin 16 3 F and OX47. One 6199, okay. So seems okay so far. Then we read in. There could be like an actual logic problem, like maybe I'm misunderstanding the spec. Which is certainly, yeah. Maybe let's go something like okay, well we're up there, we're okay. Okay, decode PES header. Maybe is there something about this? Maybe this isn't, you know, maybe something there is not, you know, like that isn't actually the right thing to do or something. Okay, just a sanity check. Okay, whatever. Bad marker bits. All right, so not getting that error. Okay, buff 0. So the flags are here. 8.3. 8.3 in binary is then 1, 2, like that. Let's print the flags here. Just because something, I don't know, something here feels. Yeah, okay, but fucking field set 01, that thing, that's totally fucked. I'm saying if the length is greater than 3, whoa, checking that. Yeah, so it's yeah, so it's going if yeah. Because then that means that we've got the 3 bytes that we care about. That's the some flags that tell you about, like, you know, metadata stuff, optional fields, and then the length of the remainder of this part of the packet. Ah, okay, cool. Yeah. Oh, look, we're already doing that, so let's dump this. These fields look very odd to me. I mean, because when I go back to here, let's get this open. Just close that one. Looks like okay, we got 47010 6F 3F 478358, yeah, blah 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 blah. Decode PES header. Where are we going to do decode packet, decode PES packet, decode header, short buffer. Maybe this is actually a, this could just be like a misunderstanding. This is all just a misunderstanding. Because the header itself can be fragmented. Maybe that's it. So let's just knock that out, right? And then yeah, like if we should just because I mean obviously we can't have 205 bytes. Just can't happen because the max packet size is 188 and that's very set in stone. I mean, we can't, we will never, in our slice, we're never going to have anything more than 188 bytes. The value could be whatever, yeah, just because we're getting it from a byte, so it could be 255, who knows. So yeah, there's that. I feel like this is a misunderstanding. So for example, what it could be is something like maybe, you know, if the length of, you know, is less than that, then it's like just, you know, else do this. So this, something like, I mean, do we want to see what happens? Like, let's just do something like that. Oh no, okay, all sorts of fucker up. All sorts of fuckery goes there, but... Oh, no, that's okay. We can just go like that, and then just see what happens or something, I don't know. The fields are wrong though. It's those fields. The fields are wrong anyway. Like even if we, it's weird shit there. Those fields are they're like that fields are invalid. So I think we shouldn't be going into here. That's what makes me feel, it feels like that. So we just go back to where we were. As I say, this byte is all fucked up. That has a, yeah, basically an invalid value. Like for so that means that it's got to decode pairs header greater than or equal to 3. What if like there's no, maybe it's this. I don't know. Let's read again the spec of sorts. Maybe it's this. Maybe it's a padding stream or this other thing here. There's another happy emu. Here we go. This is a good tutorial. Pairs, here we go. Pairs header fields, pairs packet header fields, here we go. I love the aesthetic of this website. It's good. That's in the header. I want to know if the header is there. That thing. Let's check that. Check the value of the ID. So let's get the, let's store these as, I mean, let's just, what did it say? Private stream 2. That one. Okay. So let's get the ID out. Store some stuff here, so is that pairs. Oh fuck. Alright. Pairs ID. Okay, let's store some constants here. OB1, OB1. Actually, let's do it stream padding, stream private 2. Okay, we're gonna panic. Ready? We're gonna fucking panic. I can feel it. Ready? Where are we gonna see it? There. Okay. Fuck. What? Wait. Oh. What? Shit. Damn. Thought we might get it there. Thought that was a good one. So still just trying to find out if, like, I'm not super convinced that we should be going into here. That's my hunch. Follows the header length field. One zero. So if we see 1 0, oh. Is that it? Decode? Hold on. Maybe we shouldn't be going in there. Decode. What if we read the marker bits? Let's be doubly sure. So we got the packet length, which we've read up here. What if we check these marker bits? Just in case. And then I would like to those are all bits. Must be set the appropriate flag and code the appropriate things. Okay. Let's try by is that the right bit mask even? It's not the fucking right. It's not right, is it? So we read that, and then we read the packet length, and then maybe we have the PES header, maybe. Let's check. And the byte that we care about is the marker is 1, 2, 3, 4, 5, 6, 7. That, right? So that's 1, 0, yeah. A byte and int. And marker, but okay, yeah. I want to. Marker is a byte, or even a whatever byte. Int constant 256 as byte in variable. Ah, okay. One zero. So that means that no, that isn't right, is it? It's that isn't the right bit mask. It needs to be. I need to check that the. Yeah, it isn't right. Maybe I did have the right bit mask after all. Faithful. Yeah, Marcus set. Something like that. What other reasons could there be? Is it that the pairs header flags? Extension. Oh, fuck. That's the kicker right there. The fields are like absolutely, it's just not it. So I feel like packet length. Extension, no way. Only allow for video. Get the length. Stream ID, 1 byte, 2 bytes, pes packet length. Length, yeah. No, that's not right. The length is... Okay. I'll look at my notes from the old days and see what we got. I have some old notes from when I did this once upon a time before. So let's have a look. Just going to well, no, I mean, yeah. No comment. Ah, oh, god damn. Okay. It's just, it's like... As Clogo, true grow, copy info, CRC. Okay, yeah. I fuck me, man. Packet length. Should I just not be checking the length? No, because it isn't that. It's actually the fields that are fucked up. So it's the, yeah, it's like there's some flags that have like impossible values, or very like it's I'm just reviewing now when I here it is. I mean, yeah. Okay, so I parse the PES header. If header flag, maybe I'm missing the order or something, but it seems buffer length isn't there too short. Okay, fine. Parse the PES header. Okay, let's read that function. Packet length. Start code prefix. Stream ID. Packet length. Okay. How someone can do with all this on the screen is beyond me. Keep killing everything. A bit tricky. So what I do is I actually always provide 6 bytes to decode the header, no matter what. And then that means, yeah, so, and I actually use an array. So I know I'm definitely giving 6 bytes. but the header looks different. So in the header, all I keep is 3, 4. Yeah, well, I said yeah, for like 1, 2, 3, 4, 5, 6. Yeah, 6 bytes. So what that means is in our code, yeah, how I actually do it is that I just store this stuff only. And then I have them in separate, I have these, I have all of that separately. So I have that more like up here really. So I've got the header and then we've actually got like the pairs sort of like, yeah, like here is almost like the payload, or, you know, like it's got some other structures there, which actually kind of makes sense. Actually makes more sense really, because, well, not really, I mean, but yeah, like it's kind of in the, yeah, I don't know, yeah. Either way, it's okay. So there's that. And then, oh, more people here. So oh, hey. All right, and then now if I stumble across this, oh, Britt, I see what you're just trying to... Nah, don't, I mean, come on. The accent's super similar, right? Okay, and then when I read the length of the header, which I must do, the header length, yeah, there we go. I don't care how long it is. I just kind of store the value and then don't do anything with it. No, actually, I put header length %d, but only %d left in buffer. No, sorry, no. I do check. Header length, what the fuck? Yeah, it is, yeah. And also, I haven't really got like a really strong accent either, so it kind of, yeah, that sort of blurs it a bit as well. And my dad's English, so there you go. I mean, okay, like, what I could actually do is just run the... Okay, what I can do is... Okay. Interesting. Yeah, let's do that. Okay, I'm gonna actually... I can actually download the Big Buck Bunny on with this old code and see how it actually handled it. Let's see. Well, I mean, okay, so here we go. All right, well, okay, I'm doing something wrong because, yeah, and it's something to do with the way that I actually, that length, the way that I actually check the length is not, yeah. Because, like, if I actually go hex, yeah, so that's, oh, fuck. Oh my god, oh my god, oh my god, oh fuck. Okay, alright, ready? Ready? Here we go. I think we got it. Okay. Let's test. Alright, so, yeah. Okay. So actually, that can all, yeah. And then we go, let's leave that there for a bit. Now the check that we want to check is actually, before we get to here, decode pairs, there's a rule. Okay, here we go, codec, where's codec? I'll go there. Okay, this isn't enough. And, oh fuck, wrong keyboard. Node. And the p dot payload start. Fucking, there we go. There we go. All right. Let's test now on all the tests. Probably get some other error, but that's fine. Yeah, okay, that's fine. Oh, fuck me. Oh, actually. Oh, fuck yeah, the whole fucking thing goes. Holy shit, yeah. Fuck. Okay. Now, that actually makes a lot of sense. Yeah, that actually makes a lot of sense. So, Do people want an explanation of what just happened there, or is it sort of... I basically just misunderstood the spec. And you know what? I actually remember that happening or something. It's just yeah, look, basically it was a fucking coincidence that those bits just happened to be laid out like that. Just a coincidence. And so if I'm gonna knock that off. I need to cleanse my editor here. Let me just close up some shit. Alright, where's that coming from? Let's just going. Yeah. I can just go. Alright, there we go. Yeah, so if I go back to unmarshal, what? Can go as well. All right. So when we unmarshal the packet, if I go here, all right, let's go again. What happens is that when you unmarshal a packet, one of the things that's set is this. This actually tells you that this is the start of, like, it's aligned with the start of some kind of, like, significant payload. And what I mean by that is, like, not just payload here, but I mean, like, actually a, well, it is, yeah, it's the start of a elementary stream. And if there's that there, then that means that there has to be a PES packet there. And the PES packet contains all sorts of timing information. And it itself contains like the raw video and audio data. If that payload start isn't set, then that means that there's just, the rest is just some other stuff. It itself could contain, like, you know, a bunch of raw video and audio data, but yeah, so, but that, I mean, that's basically it. So it was just a, yeah, I mean, that's basically it. So this, the go to packet, we only go into there if that's set. That's it. So there we go. nice. Okay. So now, if we actually do the thing we wanted to do in the first place, which is, but that's good. I mean, running this command actually like surfaced the bug. Oops. Oh, this is TS part. No, that isn't the command I want to run. I want to run HLS serve. So now what we're going to do is finally hook in our MPEG-TS package into our sort of self-hosted HLS service. Let's put that in there. So we go here, HLS serve. Actually, I think we're good to just run that as is. So let's give it a go. So go run. We're going to read. Oh yeah, we just run that. And then what we're going to do is send in. We need to send it over transport. Can we just do? Yeah, actually we could do this. We can just send it to loopback. Send it real time, because that's what we're simulating. Otherwise, FFmpeg will just blast the bytes to us. That can go away, and then eventually we're going to want to do MPB. Okay, so we're going to send the Big Buck Bunny to our little service as an MPEG transport stream, and then it'll serve it out as HLS, I think. Okay, looks good so far, so let's just fucking yes. Yes. Okay. Oh, that's good. Let's stand up. All right. So what this means is that our okay, we got a little bug, but that's it. It's not a joke to watch an animated bunny. Yeah, I mean, I don't know what happens to the bunny. I mean, I've only watched it about 10,000 times. I need to find out what's going to happen. Okay, cool. We got a little bug there. But that's all good. Let's pump this thing. Let's do that. Oops. Oh yeah, I need to. So this will just write it as quickly as possible. Oh, okay, there we go. Yeah, see, that's way faster. And then to larger than. Interesting though, isn't it? So that's when we encode it. All right, so we could actually have another test that that encodes the packets that we receive, because that's where we're getting a bug. So we'll go back into our MPEG transfer stream and then codec. Oh no, we'll do a test. So what we'll do is, let's, instead of just reading this one segment, let's actually read the whole thing, which I think we have stored somewhere. Yeah. There we go. Okay, cool. Packet 32891. Yeah, it is. That's actually that's actually a good title for the video series, you know, going down the rabbit hole. It's just big buck money for like months on end. Yeah, exactly. Yeah. Okay, so we are apparently p.pes pack PCR. The program clock reference, that's in the adaptation field. Yeah, okay. Okay. I can't, no, they weren't. I think it was too cold today. The birds are really bad with the cold like I am. Or something, I don't know. Yeah, how are you going? Is that the, oh, that's the PES. So it's really that adaptation of PCR. The dog was begging earlier. Yeah, that's right. Begging for more bunny. Ah, the paid work part of the day. Yeah, that's actually a good idea. I think I need to start doing that soon. As in, like, yeah, actually get paid work. Yeah. Okay, so let's review the encoding. Okay, here we go. There's our PCR. So apparently, base blah 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 is larger than max. Is that really the largest value? I mean, okay, like, you know, sure, we've that means at some point we've stored a value that's way too big. So we need to yeah. We need to fix that up. This isn't right. We want to read from. We want to do A0. That's backwards, right? Zero, 1, 2, 3, 4. Yeah, well. Yeah, this isn't right. We want to read, well, exactly as it's written there, yeah. Except that's going to be. No, I've got this totally the wrong way around. Okay, that can go. Yeah, this is all. No. This is. That's all whacked up. Then we're going to store 0, 1, 2. So from 3 onwards. Up to 0, 1, 2, 3. 8, 16, 24, 32, 49, 5, up to 5. 0, 1, 2, 3. Oh, and then 4, yeah. No. Like that. And then, let me just review that though. So let's look at the PCR. There we go. Hold on a minute, but how could it be wrong if I'm doing a byte for byte comparison, I'm getting the same values in as I was out? So we're doing something weird in the way that I'm storing it and writing and reading it back out again or something like that. It's probably the case.
And 4 is that. Yeah, okay, I can see why I've done it like this now, so I should just stick to that. So A, as far as I'm aware, it should be like this. A, it's going to be 33. Let's start with 33, so it's going to be 0, 1, 2, 3, and then 4. But then this, we only want the 1 bit from it for 33 bits. So there's that. Okay. Okay, and then and then we're good. Okay, and then the next 6 bits reserved, so remaining 1 bit in, no, so now this is, we want to read 7, what is this, 9 bits? I need to review how it's packed. Yeah, there we go. 33 bits base, 6 bits reserved, 9 bits extension. Yeah, okay, that's fine. So it's going to be look like this. So we've got 6 bytes. So this is PCR 2, 3. Oh, we can do ticks again. So, oh no, we'll do 1, 2, 3, 4. 1, 2, 3, 4. Same again. So 8, 16, 24, 32, 33, and then we've got 6 bits reserved. So 1, 2, 3. 1, 2, 3, and then we've got the extension E, and then 1, 2, 3, 4, 1, 2, 3, 4. Okay, that's the structure that we need to get out. So that's why we're doing OX80 there. Okay, and then we go A4. And then we get just that bit. Yep, which we're getting, and then A5, all of A5. Yeah, great. Okay, so that bit's correct. I don't know what I was doing with the base there. Uh-oh. Uh-oh. Okay. Maybe it needs to be... Yeah, this is wrong. This needs to be like... And then I think 0, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8.
Is that a big packet? Fucking hell. That's so weird. Like, why does it... Okay, hold on. Let me run... Packet 4. Oh, no, I'm still fucking it up. Values count is base times 300 plus extension. Yeah, okay, whatever. That's OPCR. Wow. Better than it was. Yeah, well, that's true. Yeah. Okay. Go back into the old archives. Whoops. Okay, so yeah, right, nice. Okay, so in this other version, I just stored the I just stored 6 bytes just as an array. So that, I mean, that works, sure, but it's a bit, yeah. And then whenever I wanted to do anything with it, I had like a method on the type that would just convert it to something that was useful. So which is not, yeah, it doesn't, yeah, I can see that's a bit clumsy that way, just because then you can't do normal sort of like arithmetic with it. You have a method and then you get this number, then how do you put it back in? Unit 64. Okay. That's not helping. Looking here and see what our happy emu Aussie guy actually says about the program clock reference. Here we go. Here it is, yeah. 33-bit program clock reference. Yeah, I mean, so it's, I'm pretty sure I got it right with this layout here, right? That seems okay. Because it's, you know, we got all those bits and then 33 there. So 8, 6, 7, 24, 32, 33. Then 6 reserve bits there, and then 9 extra. So to me, yeah, am I getting this bit wrong? If it's 64-bit, then is that a 64-bit uint? Like, is that a uint 64 big endian encoded? Because that's all the way there is 33 bits. And then, yeah, it must be there. It must be. So 1, 2, 3, 4, 5, 6, 7, 8. Oh. On the 6th. Ah, am I one down? Right. So that, and it's just an operation on the 5th one. Yeah. 1, 2, 3, 4, 5. Oh no, I think no, that gives me a byte. Most significant. Yeah, that's, yeah. So initially I had the zeros here. But I'm kind of confused now. Is that... So this way, so this is... But if it's a big endian encoded, then... I don't know, it just feels weird to me. It's still... But then in that case, then I would have it the other way around, right? I'd have A4 and then, yeah. So I'd read it like, maybe it's like that, with the zeros there. Maybe it can't be because it again doesn't feel right. Yeah, I'm totally not doing it right here. 0, 0, 1, 2, 3, and then that. Maybe this isn't right. Have I kind of, I might have gotten that wrong. The big endian encoded. Oh, I need to get like a diagram or something big. Let me do it in, actually let me just do it in the REPL, okay, let's go. Okay. Let's just divide it by 2. Okay. And then let's put it into a, let's print out the binary encoding of it. So first we'll do, how many, 64, so we'll need 8 byte, and then let's do big endian first. So I'd put U in 64 into B. And then we'll do, so this is, let's call this big, and this is little. And then at the end, let's print out, I'll just do it like this. O64B, print out 64 bits. Little. And then that, and let's just grab that, and then this is the big. Okay, I need to do a different number. What's something that I can test this on? Like, do maybe. Well, okay, instead of doing 64, let me do like, maybe do 30. Or could I do... I can do that, I think. Of course, I just realized I'm doing this wrong. This is there, like that. There we go, yeah, that's what I want. Then, oh wait, B, whoops, B. Okay, here we go. All right, yeah, so this is the little endian, this is the big endian encoded. So, oh, fuck, okay. But the bit order is this. Yeah, right, okay. Here we go. I feel what needs to be done is parse as you said and then shift in that 33rd bit. Yeah, but how do I store the value? Oh, like as an extra byte and then put it in, or? Because I guess what I want is just a single, like, number that you can, yeah, exactly. And that's, yeah. And I think that's what I'm trying to do, but because I suck, I can't do it, yeah. Read the first 4 as U32, cast as 64, and then, yeah, nice. Yeah. Yeah, okay. Yeah, that's good. Nice. I don't know why. It's funny, like, after all the fucking around, like, what we were doing before was so much harder, and now I'm like, wait, how does it work again? Okay, so we're going to go... I'll need to do... I'll just do this. So we'll read it from that up to, oh no, sorry, that, right? And then base is actually even 64 of that. And then base, I want to toggle the, oh no, if I shift it and then, right, and then I'll shift this to some direction. I could do that and maybe just do that, shift it to some direction that I can't think. No, that's right, yeah, and then I'm gonna go, and I'll get, so now I've got this bit here. I need to put that in the right place. So it's the, yeah, this is like the, so the final one is, let's just get that first. So it's A4, right? And then need to, so that'll be A4. Here we go. Base equals base shifted left 1, and then A5, or A4, I guess it'll be that. But how can I... because now I'm going little. Hold on. But if I... Okay, yep. Yeah, that gets me... And then 7, and then... Yeah, okay. And then move it along all the way. Maybe I need to draw it out. Yeah, and then I need to put that. I need to toggle. Yeah, I see. And I've got my byte, and I kind of want to put that into the base now in the right position, wherever that is. Could I OR it with the? Could I do the bitwise OR on the base? And I could just go base or equals. Maybe this needs to be a... I could do uint64 here. Just to keep it in the thing, and then put the whole thing across, like... Or just... And then... Oh, it's so tricky, this. What am I doing?
it's 24 bits. Yeah, that makes sense. And that's, yeah, okay. So 64 bits all the way until we fill up to there. So that means that this is going to be here we go. But this has got to be shifted all the way, like a long way. Or shifted left, sorry, yeah. Like a long way, like shifted 20, 32 positions. Yeah. I think that's it. Like that. This is also so say we were encoding this many ticks. Let's say we're encoding that. So let's get this diagram back out again. Okay. So we want to pack. So we've got 4, 8, 16, 24, 32. Do another one. Yeah, okay, that's good. 8, 16, 24, 32. Okay. And then we go, hold up, let's do this again. So in this case, I mean, in our case, we'll have an array of 6 bytes. So let's just call it 6, those ones. So 1, 2, 3, 4, 5, 6. And our so it's actually going to be yeah, okay, I get it now. So actually the value in our case is going to look more like this. It's going to be let's say we have 6 bits here, so it's going to be 1, 2, 3, 4, 1, 2, 3, 4. Or let's do like this: 1, 2, 3, 4, 5, 6, 7, 8. 8, 16, 24, 32. Whoops, 31, like that. And then we're going to have, let's put this like this, just for clarity. And then we're going to have 6 reserve bits, 1, 2, 3, 4, 5, 6, and then the extension. And then there.
Is that one bit the least significant? Oops. I think, yeah, that one is the, let's have a look. Let's see. So that's the, in our case, that bit, is that that's the least significant, I think, yeah. Yeah, it is, yeah. So I actually do have it backwards, don't I? I have it backwards. It should be the other way around. It should be like this. I think this is actually this is it. These are the bytes. So not that, but this one. I'm pretty sure that's what we get. No, fucking it's not though. It's not. No, it's not. It's this thing. It's this this thing here. It's that. I've got it confused. I'm super confused now. It's like I've forgotten something, or I don't know. It's weird. So I've got a 33-bit integer here, then 6 bits, then 9 bits. To me, I thought that was it. Because that's what we're going to get from the network. Like from the network, you know, from the outside world. So is that, yeah, this feels right. So does that mean then that, say if this were 64 bits, it would be really like, you know, I thought. But it's not, is it? It's that way around. So what's 3? Yeah, okay, yeah. Well, 32. It's gonna be the same, isn't it? Yeah, the same. Oh yeah, 4, yeah. Yeah, I got it. I got it. It's like this. It's like this. This, and then it's a 0 OX01. 1, 2, 3, 4. I think that's it. I think that's it. And then that is going to be the well, yeah. Let's just look at that. Or not. Ah, okay. Yeah. Yeah. Yeah, because then that's shifting it all the way over to here. Because in this case, our little 33-bit one is going to be like this. Yeah, I mean, minus, get rid of that. So it's going to look like this. So that's 33, big endian, uint 33. So then let's dump. Yeah, because then we're getting the lock that off. I 32 I, yeah, and then we're casting to unit 60. Yeah, and then we go. Okay. Okay, that's fine. Now, when we encode it, let's try again. Or we could, yeah. Seems okay to me. Wait, what? How come? How did I not get that? Did I not copy and paste that correctly? Anyway, yeah, okay, let's grab it. Yeah, that's yeah. Because yeah, I get it. Because again, yeah, we're making room for it, and then we're putting that in, and then we're shifting it right to the 7 anyway. Yeah. Because we're shifting it, yeah, one, and then we're making room for that one. Yeah. No, but then that isn't. No, this is different because I want to store. I want to read this. Like I want to read this uint 32. This doesn't seem right to me. Because. The most significant bit is let's see if I'm reading it okay now. So here I'm we put it in there. Okay, fine. We could do that, and then I'll just do. So we got that, and then we want to we want to chop off the, like, or, well, I mean, look, I think I need to call it. My brain's fried. Just can't, I'm just looking at it going, yeah, brain's fried. Yeah, I'm just looking at this going, I just don't know what I'm looking at anymore. So, yeah, because I... No, it's true. But maybe this is all, like, maybe, you know what could also be happening, right? Is that, like, I'm packing a PCR when I shouldn't be or something like that. No, come on. No, don't worry. Jeez. So it's like, it's like I can't... Maybe there's just a bug in the way that I'm detecting this thing or something. I don't know. Like, I mean, that number's fucking huge. How the fuck's that? So kind of, maybe I'm assuming something's wrong when it's not. That's probably what it is. So probably when I do like I don't know, maybe there's not actually a PCR in there or something like that. Maybe I'm just, you know, just not getting it. Which could well be the case here. Yeah, but anyway, that's fine. Look, I think at least I can, yeah, what are we doing here? Let's do that, and then we'll just come back to that tomorrow. Yeah, okay. All right, well, look, yeah, tough one. My neck, really, my shoulder, man, it's fucked. That one. Oh. So yeah, all good. Okay. Do that, and then why don't we do a rady thingy? That's good times, right? No worries. Thank you. Yeah. Oh. I don't need to swap to a different topic for a little bit, maybe. Very cool. Yeah. Okay. Oh, yeah. Yeah, nice. Yeah, I will. I'll go into there. That's on the, yeah, I'll... Nice. Catch you later. I'll go there as well. How do I quit out of this? So this one. Ooh, too many fucking computers. Yeah, that goes here. All right. I'll hop out of here. All right. Thanks, everybody. Good night. Oh, nice. Okay. Yeah, will do. Yeah. Nah, thanks, everybody. See you next time.